A tuple is a collection data type that is ordered and immutable. It is similar to a list with the main difference that a tuple cannot be changed after its creation. A tuple is often used for objects that belong together. And yeah, let's have a closer look at tuples and what you can do with them. First of all, a tuple is created with parentheses, and within these parentheses you put each element that you want separated by a comma. So for example, let's put in Max, 28 and Boston, and if we print this, we see all the elements inside our tuple. Now the parentheses are optional, so we can leave them away, and it's still a tuple. One special thing is if you just want to have one element inside your tuple, and even if you put it in parentheses and you write it like this, then this is not recognized as a tuple. So if we have a look at the type of this, then this is recognized as a string. So what you have to do then, you have to put a comma at the end. Even if it may look strange, that's the right syntax. So now it's recognized as a tuple. You can also use the built-in tuple function to create a tuple from an iterable, for example from a list. So say Max, 28 Boston, and if we print this, then we also have our tuple created. Now if we want to access elements, we just do that by referring to the index. So if we say item equals my tuple, and then inside brackets we specify the index that we want, and the indices start at 0, so index 0 gives us the very first item. If we print this, then we see we have Max, index 1 we get 28, index 2 we get Boston, and if you use an index that is too large, we get an index error, index out of range, so be careful here. We can also specify a negative index. -1 refers to the very last item, so that's Boston in this case. -2 is the second last item, and so on. Now what happens if we want to change the elements inside our tuple? Like with lists, if we write my tuple and then get the first index and assign it to a new value like Tim, and if we run this, then we get a type error. Object does not support item assignment. So this is not possible because a tuple is immutable. Now we can easily iterate over a tuple with the for in loop. So for I in my tuple, colon, and then do something. In this case I just want to print the element. So then for each element we print it. And we don't have to call this I, we can also call it, for example, X or whatever we want. We can also easily check if an element is inside our tuple with an if-in statement. So if Max in my tuple, and then we say just print yes, and otherwise we print no. And if we run this, then we get a yes, so Max is in our tuple. If we check for Boston, it's also inside our tuple. If we check for Tim, then we get a no. So very easy syntax to check if something is inside our tuple. So let's talk about some other useful methods that you can do with the tuple. For example, create a tuple with some letters in it. And first of all, if we want to get the number of elements inside our tuple, we can just use the leng method, so leng of my tuple, and this returns 5. So we have 5 elements. If we want to count some elements inside our tuple, so we can use my tuple dot count, and then we count the letter P. So then we see we have 2 letter P's inside our tuple. If we check for the L, we get a 1. If we check for O, which is not inside our tuple, then we get a 0. And we can also find the first index of some specific element. So for example, my tuple dot index of P, and if we run this, then it returns the first occurrence of this element. So this is at index P. For example, if we say A, then we get index 0. If we want to get the index of L, then we get index 3. And if we check for an element that is not inside our tuple, then we again get a value error. So be careful here. We can also easily convert a tuple to a list and vice versa with the list and the tuple function. So if I say my list equals, and then I use the list function and put the tuple here, then I get a list out of it. And I can convert it back. I say my tuple 2 equals, and then the tuple function, my list. And if I print this, so then I have a tuple again. Now let's talk about slicing with tuples. So slicing is a very nice way to access subparts of your tuple with the use of the colon. So for example, let's create a tuple with some numbers in it, and let's create a tuple. And then the syntax is we use the tuple, the original tuple, and then inside brackets we specify a start and a stop index. So for example, from 2 to 5. And if we print this, then we have number 3, 4, 5. So this goes from index number 2 to index number 5, and but the last index is not included. So it only has index 2, 3, and 4 in it. So if we don't specify a start index, then it starts all the way from the beginning. And if we don't specify a stop index, then it goes all the way to the end. Now we can also use an optional step argument. So by default this is 1. So in this case it goes all the way from beginning to the end with a step of 1. And if we put in a 2 here, for example, then it takes every second element. And we can also use a negative step. So this is a nice little trick to reverse your tuple. Now we can let's talk about unpacking. So if we create a new tuple, like at the beginning, let's use Max, 28, and Boston. Then we can unpack it. If we write at the left side, we write our variables, so name, age, and city, and then just say equals to my tuple. Then we get each separate element. And the city. But the number of elements that you put in here must match the elements inside our tuple. So if we just use 2 elements here, then we get a value error, too many values to unpack. But what we can do is we can unpack multiple elements with a star. So for example, if we use some numbers, so 1, 0, 0, 1, 2, 3, 4, and if we want to unpack this, so let's say I1 and then a star, and say I2 and I3 equals to my tuple, and then if we print I1, this is the very first item. If we print I3, this is the very last item, and if we print I2, then these are all the elements in between, and now converted to a list. Yeah, so one more thing that I wanted to show you is to compare a tuple and a list. And because a tuple is immutable, Python can make some internal optimizations, and thus working with a tuple can be more efficient sometimes, especially when working with large data. So let me copy this in here. In this example, we create a list and a tuple with the same elements, and then we use the sys.getSizeOf method to return the number of bytes in both of them. And if we compare them, then we see that a list is larger even though it has the same elements as the tuple. And also it can be more efficient to iterate over a tuple and also to create a tuple. So if we compare, if we use the timeIt method, so there's a very nice method in the timeIt module, timeIt.timeIt, and then you can use a statement and repeat this specific number of times. So in this case it's 1 million times. 1 million times we want to create a list, and 1 million times we want to create a tuple, and then measure the time. And if we run this, then we see that it took much longer to create the list than to create the tuple. So yeah, keep that in mind, that working with tuples can be more efficient than working with lists.